Hello, I'm Alan Fulton, University of California Irrigation and Water Resources Advisor, serving the northern Sacramento Valley in the counties of Tehama, Glenn, Colusa, and Shasta. Welcome to this brief tutorial on reading your weekly crop ET reports. This is an example email report that you might receive if you are a grower requesting these reports in the northern Sacramento Valley. We're going to take a little time just to step through the organization of the tables and a little bit of the thought process that you might consider as you read it. To begin with, each week you will get a report and it will have a date indicating the most recent 7 days that is reporting for. So in this case, this report was from May 29th through June 4 of 2020. Next, I'm going to take you to the table that says Tehama County. We're going to focus on the table that says Tehama County, Gerber South, Simis Weather Station. For purposes of discussion and example, we're going to focus on the crop of almonds. The number that I just highlighted in green is the estimate of crop evapotranspiration, 1.72 inches for the past week of water use, which is corresponding to the dates May 29th to June 4th of 2020. Now you'll notice that we jump down to the lower half of the table. The lower half of this table adjusts for irrigation efficiency. And we'll talk about this in greater length in a few minutes. But for the moment, you'll see that the number highlighted in yellow is 1.9 inches, which is higher than the estimate of 1.72. What we have done is added 10% more water into our ET estimate to adjust for inefficiencies with our irrigation system to make sure that all areas of the orchard are adequately irrigated. And we have adjusted it for a 90% efficiency, or adding in 10% more water. As the table shows here, we also give you estimates for 80 and 70%. If you feel you need to adjust for more inefficiencies and allow for more water. Highlighted in the light purple is the rainfall that we received in the last 7 days, which again corresponds to these 7 days from the end of May to early June. As I have highlighted these numbers, some of the things that I would think about are I'm probably going to base my irrigation needs based on this 1.9 inches of water for the past 7 days, building in some accounting for the non-uniform application of water. I'm going to compare it to the rainfall that was received in the past 7 days. And as you can see, the ET estimate is considerably higher than the rainfall that was received. So this will be the first indicator of the need for irrigation and start to give us some idea as the possible amount of irrigation needed. Slightly less than 1.9 inches, maybe accounting for a little bit of the rainfall. And we'll talk about that in other tutorials as well. This number is the running total for almond. We're simply summing, adding all of the weekly reports of crop ET since March 1st, which was our observed estimate of when vegetative leaves began to leaf out on the trees. And so what this is telling us, since March 1st through June 4th, our estimate of total crop evapotranspiration is 13.78 inches for the Gerber area based on the weather measured at the Gerber station. We also keep a running number of total rainfall accrued in the spring since leaf out. Now we don't have the space to keep an accrual for each crop in the different leaf out dates. So we keep a running total for almond, which is the earliest deciduous crop that leafs out in the valley. This means that the rainfall received since walnut or pistachio leafed out will be less because the window of opportunity for rainfall was shorter. So you want to keep that in mind. It is possible to look at other reports and back out those numbers, but that's too complicated to get into right now. The other thing that we show in this table is we give an estimate for the next 7 days of crop ET for those who are trying to look for a forecast or planning. Now, this is not a forecast based on the next 7-day weather. This is rather an estimate based on the historic averages for this weather station. We elected to go to this point with the historic average rather than the forecast because we tried it for a couple of years to base it on the NOAA forecast, and we had some experiences with quite high variability in the forecast, leading to a lot of corrections being made after the fact. Okay, so one of the purposes of this report and the reason for reporting multiple weather stations is so that we can quantify the effects of growing crops in different farming regions, and it's just for the fact that the weather is different. So here, if we look at a weather station that's about 70 miles further south and quite a bit further west, you'll see that there's indicators of some significantly different weather. This is Colusa County, the Williams-Simms station. Here you can see that for the same period, 7 days, crop ET was estimated to be 1/10 of an inch higher at 1.82 inches. When we adjust for the inefficiency, we are then considering a crop water use of 2 inches instead of 1.9 inches. Here is where we start to see the real differences between the regions. The rainfall in the past 7 days was slightly less. The cumulative ET since leaf out on March 1st is a fair amount higher, 10% or more, than at the Williams station than at Gerber. And the rainfall is much different, 4.69 inches versus 0.9 inches. So based on this weather information and these ET numbers, we would expect that almond growers in this area have been irrigating earlier in the season and more intensively since then versus further north at the Gerber station. And again, here is the forecasted estimate of the next 7 days, again, based on historic averages. Now, as we spoke about in other tutorials, you can also get these reports online at your convenience. I'm just going to walk through again very quickly. Same information, just a different layout. So this is for the week of May 29th, June 4th, just like the previous example. It's for the Tehama County Simms Station, Gerber South, number 222. It's for almonds. The unadjusted ET, no adjustment for irrigation inefficiency, 1.72 inches, the exact same as shown in the other table. Adjusting for a 10% non-uniformity, we estimate that the crop ET is 1.9 inches. We show the past 7 days rainfall, 0.17 inches. The cumulative seasonal water use since leaf out on March 1, 13.78 inches. The cumulative rainfall since March 1, 4.69 inches. And the forecast for next week being approximately 1.86 inches. And if you're looking for a different information for a different region of the North Valley, you would then scroll down and look at the list of other weather stations. So that's pretty much how you navigate the table and seek out the information you need for your specific situation. Now, I wanted to spend a little bit more time on the lower half of the tables, some of the thought process that goes into that table and why it's being offered, okay? So irrigation efficiency is defined by the water applied for beneficial use versus the total water applied. Let me restate that. Irrigation efficiency is the water applied beneficially versus the total water applied, okay? So beneficial uses can be justified as irrigating to meet crop ET, crops needs, can be irrigation to manage salinity, can be irrigation to manage frost control. It can be irrigation to cool the orchard in the event of a very hot period, say at bloom time for some crops, like say in prunes. So there's a number of beneficial uses for our water. Our main sources of losses of water are due to non-uniform application of the water that's related to the maintenance and performance of our irrigation systems, perhaps runoff if we run the water too long, generating a lot of runoff, and if we have rolling topography, that it runs off the field. And maybe most likely in the springtime, not so likely, probably in the summertime, deep percolation. So I wanted to review for a minute the concept of irrigation system uniformity, why it's important, and why we try to account for it in these weekly ET tables. So this is an example of an irrigation system that applies the water very uniformly. If we take this picture this almond orchard and we split it in quarters, and we consider this quarter to be closer to where the pumping pad is, maybe the pressure is a little higher and a little less pressure losses, and we consider this to be the far end from the pumping pad, more pipelines, more pressure losses, possibly more opportunities for plugging, different things like this. We get differences in the amount of water that our micro sprinklers or our drippers put out. In a high uniform application, which this is an example of, you see that the highest average flow in one quarter of the field represents 1.65 inches, and the lowest quarter represents 1.35. The average across the whole field is 1.5 inches. Now here's a scenario where the application rates are not as uniform. On the upper quarter, closest to the pumping pad, where pressures are probably higher and better, we apply on average 2 inches of water. On the low end, after significant pressure losses, maybe due to undersized pipe, maybe due to plugging, maybe due to plugging at your filters, many possibilities. We only apply 1.05 inches of water, so almost 2 times as much water on the top quarter of the field as the low quarter of the field. That said, the average applied water is still 1.5 inches across this orchard. So the same average amount put on, but a very different spatial distribution of it. This scenario 1 represents a high distribution uniformity of 90%, and this scenario represents a lower, what we would probably consider an unacceptable DU of 70%. So this is what we are trying to adjust for. We want to operate high-performing irrigation systems, but then we want to account in the ET need extra water to account for the fact that we just can't distribute the water 100% uniformly across the orchard. It's not physically possible. Irrigation distribution uniformity affects your power bill. When you have a uniformity like this and you irrigate more to make sure this area gets irrigated, you're going to pump longer. It impacts nutrient distribution, especially if you inject your fertilizers through your irrigation system to apply them. But it can also affect broadcast fertilizers just by the amount of water that's infiltrated and the depth the nutrients are penetrated into the root zone. It influences the orchard's uniformity and the amount of tree loss. You can expect to have less uniform tree growth. Smaller trees that see less water here, potentially bigger trees here because they see more water, until perhaps some of them begin to show root rot and other symptoms of too much water. And so over here, because the uniformity is more close to each other from one end of the field, we would hopefully have more uniform trees across the block. The reason we talk about this for a minute, to take time out to do this, is that low distribution uniformity defeats efforts to schedule irrigations better. So it's just really important that you give time and consideration to the maintenance and repair of your irrigation system, knowing how well it's working. Because if it's performing poorly, you're going to be a lot less successful applying this crop ET information and trying to schedule your irrigations more timely and more effectively. So here's some guidelines to help you maybe determine what column in the lower half of that table or what irrigation efficiency you might choose. Now you can see here that for the systems that we mostly use, microspray, surface drip, and 85 to 90% efficiency is a reasonable assumption, a reasonable number to use, particularly on new systems. Now, as the systems age, and depending on your maintenance and repair of them, that can be a different story. For solid set sprinklers, some of the hand moved pipe systems, different things that we still have out there, the irrigation uniformity might be a bit lower, more in the 80–85% for newer systems, and even lower for the few areas that we still do surface irrigation with furrow or basin. Below this table is a citation, UCANR publication 8571. It's a free publication online by Daniele Zaccaria. You can certainly locate this publication and learn more about irrigation efficiency. If you're really unsure about what is the proper irrigation factor for your orchard when reading these tables, I'd suggest one of two things. First, I'd suggest contacting the Tama County Resource Conservation District in Red Bluff, the Tama County Mobile Irrigation Lab, a service that's been very active and effective since about 2009, and see if you can arrange an appointment to have someone come out and do a thorough evaluation of your system and report back to you what they have found. If you find that there's a waiting line for the service or you're more of a do-it-yourself type, I would refer you to this second publication. It's a publication on irrigation and how it affects nitrogen management. And it's a free online publication. And on pages 5 through 8, it will walk you through some simple ideas and concepts of how to evaluate your own pressurized irrigation system. And it also goes into how to evaluate surface and furrow systems as well, basin and furrow systems. So when you're reading the table and you're thinking about, do I look at the number at the top half of this table, or do I pick out the number on the lower half considering irrigation efficiency? Here's what I'd like you to remember. You don't have to absolutely use an efficiency level. You can simplify reading the table by just concentrating on the upper half of that table, the email table. If you don't adjust for irrigation efficiency, you are assuming that you can irrigate at 100% efficiency, which of course we know is not physically possible. There are some possible consequences and offsets. By doing this, you might be erring towards under-irrigating some parts of the field in comparison to others. However, the trees with deeper root systems and more stored winter soil moisture might compensate, so there may not be much consequence. On the other hand, you may choose to say, yes, I do want to consider irrigation efficiency in the crop ET report each week. And because you know you can't irrigate at 100% efficiency, so select the level you think best fits or get it measured, as I've suggested earlier. The possible benefits and consequences of using the efficiency level are it prevents under irrigation, and it's a possibility you grow more uniform crop. However, if the irrigation efficiency is too low and you start adding extra water to make sure the low areas get enough water, there's a greater chance that this will lead to over irrigation in some areas of the field. You may find it's better to improve the irrigation system uniformity. In other words, make some repairs, some corrections to your system elevate your level of maintenance of the system than to overly compensate by applying too much water. It's generally thought that too much water, when you start contributing to root diseases and decline of trees, that's a situation that makes it much more difficult to sustain the orchard. It's a little bit easier to recover if there's a slight bit of under irrigation going on. So I'm about to wrap up this tutorial. In other tutorials, I mentioned that when you receive a weekly crop ET report, it's possible to determine the crop coefficients being used in any single report each week for any crop. And I'll give you a little example right here. So this is again for the recent report, May 29th to June 4th. It's for Tehama County, the Gerber South Weather Station. I'm going to use the prune example. You'll see that the pasture ET from the SEMA station is estimated to be 1.72 inches, prunes 1.65. And if you recall from an earlier tutorial, the crop coefficient is simply the ratio of the two, the crop ET over the grass reference ET. And over here, I show you the math. It's 1.65 divided by 1.72. So the crop coefficient being used for prunes on this week in this report is 0.96. So that concludes a brief discussion on how to walk through these reports as you read them and some of the things to think about. In upcoming tutorials, we will take actual data and we will talk about how to relate it to your irrigation system, to calculate the actual possible hours of irrigation needed. And we'll also look at it, how it relates to soil and root zone depth, as well as tree stress. Thank you.